This is going to be a continuation of the unboxing of the Yes Welder 205P Pro that we found on Amazon for, I think it's like $192. Under $200, you guys can get into this to actually understand if this is something for you or not. The problem is everybody's always starting in the wrong scenario of what they need. So we just want to jump right into this so you guys understand what we have, what settings, and why, so you can get right to using your welder. On the Yes Welder, we have our amperage set to 43 amps. We have it on the high frequency TIG setting. And the reason that we have it set at 43 amps is because we need our direct correlation with the sheet metal that we are going to be welding, which is 19 gauge. This is cold rolled 19 gauge. It is 43 thousandths. 43 thousandths equivalates to the same for amperage. We go into a little bit more detail in the unboxing video, so that's why we're setting this at 43 amps. If you're welding something thicker like 3/16 and you have 180 thousandths, you would set your amperage to 180 amps. That is your starting point for all your amperages. Can you set them higher? Yes, but what we want to do today is break down the basic fundamentals. If you set your amperage for that piece of metal that you are welding, the next thing we're going to get into is the gas. You're going to be needing argon. We have the gauge set at about 20 to 25 CFH. That is coming down to the actual torch that it comes with. Now this is a push button torch that we just disconnected and we added on a foot pedal just for ease of understanding what you're gonna normally see. The reason that I like to use the foot pedal is because you can feather in and out of the amperage, where with the trigger you are just on or off. We wanna break this down into something you can practice and not have bad habits right out of the gate. We are using a number 6 cup and a 3/32 tungsten. We've already showed you guys the internals workings of this torch. So if you need more information on this, see the unboxing video. Currently, we have this welder plugged into 220 volts. This machine can be plugged into 110. It does come with an adapter. Just know that obviously with 110 volts, in this welder, it can automatically switch. You don't have to do anything special. But what we have noticed with testing it is that you're only getting about half of the amperage. So if you need, call it 40 amps and you're plugged into 110, you're realistically probably only going to see about 20 in relation to how it actually works under 220 volts. It definitely works better. Let's jump into step 1. If you don't have the amperage set within the range, you're going to battle this more. It's not to say that you couldn't set the welder at max amperage and still do this. But if we're talking about breaking down the fundamentals and you're new to this, then you want to be in the range. The reason is your pedal, as you push down on the ground with your foot, that is a rheostat. A rheostat is whatever you set the amperage on the machine to, when you press the pedal all the way down, that is the max amperage that you are going to get. And when you are dealing with thin sheet metal gauge that's 43 to 50 thousandths depending, it's important because if you make one small move on that pedal and you're trying to feather something out nicely, you're making a drastic move if you have the machine set on 200 amps versus having a little bit more adjustability trying to get in the range that you need to be. You can also overcook the material where the welds don't look that nice, which sheet metal is going to look completely different than a weld that you would have on 3/16. I think people get used to seeing all the bright rainbow colors. Sheet metal is not that kind of animal. So having the correct amperage, we don't want to overcook the panel, because if we have way too much amperage, we're going to have even more warpage that we're going to have to deal with. The other factor here is the argon flow. If you have too little or too much is also not good. Too little, you don't have enough gas coverage. Well, what is the argon actually doing? It's creating a shield around your weld pool and keeping everything clean. It's keeping it away from your tungsten. It's keeping your pool and your filler rod as you are adding everything from being contaminated. So if you have too little, you don't have enough shielding. Does that mean that you're welding in an area that has a little bit of a breeze? Or do you have the door shut where you can actually control your environment? Too much argon flow will actually cause a turbulent flow where it doesn't want to just keep everything clean. It will actually blow itself around and it causes more issues. So if you come up with a good starting point and you're using these standard number 6 cups, 20 to 25 CFH is where you want to be. We want to jump right into this and just show you guys some dry running. So step 2 in this is the torch technique. The tungsten stick out, a lot of times people can't see what they're trying to weld and they're in the wrong position with their hands. Most people I see have the torch held down at like a 45. And that may be more common for like a MIG welder angle. And I think that everyone thinks that's just the standard that you would always hold the torch at. However, a TIG torch wants to be more straight up and down and perpendicular with your weld pool at about 15 degrees. Having a 15 degree instead of a 45, you're controlling the puddle's pool. If you have the torch angled down, your pool becomes oblong and it does not create those nice stacked dimes that you're used to seeing online. Outside of that, the cup diameter, typically you do not want to have the tungsten sticking out more than what the radius is of the diameter of the cup. If you're going to have it sticking out a little bit farther, well, then you may want to up your argon flow slightly and find out what works for you, especially if you're trying to get into a tight spot. But for the purpose of this video, we want to keep things very, very basic. As mentioned before, this is 330 seconds. The other thing that goes into having the tungsten is the way that you grind the tungsten. We ground it with a drill on a belt sander. I do have a tungsten grinder. However, what I was practicing, it was making a very sharp point in the tungsten, which is directing the arc deeper down in for a more thicker piece of steel instead of dealing with sheet metal. Sheet metal, we want to grind the tungsten where it's more of a dulled point. What that's going to do is it's going to keep the pool and the arc length more controlled out on the surface. If you have a sharp point, it's going to be putting a lot more amperage down into the metal, and you're going to end up with the sheet metal wanting to blow away from itself when you're doing a joint. The distance that you travel over the sheet metal, you want to be really close. I think a lot of people float too high, and if you think about this as a flashlight, and I'm going to use like a standard mag light with a nice round lens, if you are close to the weld pool, then your weld is nice and small and controlled. But if your torch is up too high, and we're talking a ½ inch, if you're up a ½ inch, that's too high. You want to keep this so close to the metal that we're just practicing the fundamentals of floating. We want you to come in, get used to touching the sheet metal so you know where you are, and then slowly come up. At that point, we are locking our hand movement and our technique and our travel speed. If guys are, you can use your wrist, and this is what it's nice about TIG is art. This is so many different ways that you can do this, but whether you're moving your hand or your arm, I see a lot of guys that when they come to our classes and we're teaching TIG, they're trying to hold their hand up higher and they're too focused on not dipping the torch instead of finding a place that's comfortable. I would say TIG is 90% comfort. If you're not comfortable and you don't have a steady hand, this is going to become very difficult. Consistency is key through all of this. So we want to find what is comfortable. And for this TIG torch, it's a bit bulky, especially for what I'm used to. But if you can hold the torch like a pencil and have your pinky almost like a pinstriper where you're holding it just above, I would say the rule of thumb is be about a 1/16 away from the metal if you can. And you just want to lock that and drag your hand across. What we're looking for is keeping the torch steady, 15 degrees, and moving so slow that we're watching the weld pool just slowly develop. We're going to be looking, as we start to strike an arc, for a heat affected zone, the haze. The heat affected zone, if it starts growing out wider and wider, then you're moving too slow. The whole purpose of setting our amperage is controlling our heat affected zone to be one nice, uniform, continuous weld. You can weld sheet metal in small stitch welds, or you can weld them continuously. I will tell you for the third segment of this video that we're going to do in continuation of this one, I would suggest practicing continuous welds on any patch panels that you're going to do. When it comes to the auto darkening helmets, I have found that a lot of times when I was struggling in the beginning, I had my helmet set up for the MIG. The MIG is a lot brighter because you have a lot brighter, a lot more amperage going down onto your sheet metal. So what I did was I actually turned the shade down on this particular Miller T94 is set at 8 with a sensitivity of 6. And then I found that I was able to actually see the weld pool. It's such a big factor that this is low amperage. It's not going to be so bright. A lot of the videos that you guys see online, it's because they're using 200 plus amps. Things are very bright, easy to see. When you do sheet metal, it's so dim that even if you have somebody, like when we're teaching our class, standing back here, they can't even really watch because their auto darkening helmet is coming on and off. So set it to a lighter shade, you'll be able to see more and you can get in closer. Also, when you are dealing with being able to see when you start your arc, we have this here light. That light is just a real cheap Amazon light that we stuck onto the top of the helmet. You can angle it where you need it to be. It just makes it easier for setup, especially when you're down in a car in a tight spot. We will link it in the description. All right, enough blabbing. Let's jump into step 2. Getting comfortable with the torch. Even if it's the weight of the cord pulling down on you, I always have it behind me. I also have this hood cover. It keeps the glare off coming into the back lens of your helmet hood. This one's made by Lincoln, also found on Amazon. Should be able to find a link in the description, I believe. Enough blabbing. What we're looking for here is just practicing the fundamentals that we talked about. Consistent distance from the sheet metal, travel speed being consistent, and we're going to do this a few different ways to show you guys where you're off and where you can pivot. Here I'm down, and as I come up, I'm going to slowly depress the pedal, and this is keeping such a small puddle that we're really not introducing a puddle at this point. We're just trying to control. Now you can see as I push the pedal down more, we have a puddle. Now, you can do a stacked type dime look, but honestly, when you're doing sheet metal, it's easier to practice just pedaling down. We're trying to keep the puddle uniform. And when we stop and we look at our heat affected zone, this heat affected zone, as I'm showing you guys and staying in one area, you can see how much more it has grown side to side. There's going to be way more warpage. Really, what we want is we want to be about the width of we are right here in the middle, which is about an inch. As we started the arc, we stayed here for too long. When it comes to sheet metal, you want to get in and get out as efficient as possible, and you don't really want to be sitting and hovering in one area like you would with standard tubing or 3/16 steel. You want to find that consistency, that balance, and just drag it through the same speed the whole way. The only time you're going to even wait a little bit is really at the very start. And quite honestly, this comes into, if this is 43 thousandths of an inch and we have the welder set at 43 amps, the start puddle is usually too slow. Now I would play about 5 amps at a time. So what we're going to do is we're going to up this to about 48 amps. What that's going to do is where we had the big heat affected zone in the beginning, waiting for it to heat up to temperature and then continuing our melting point, we're going to get in there faster so we can slowly depress the pedal down, and then as it gets hot faster, we can let up just a hair. Now remember, that hair is very minimal and every welder is going to be slightly different, but what you're just looking for is that puddle to form and just maintain a nice round dragging puddle. You don't need to be fluctuating in this scenario. We're just going to slowly go down and hold it and drag it for consistency. If you start traveling and you do not see the puddle, then stop and relocate yourself in a position that you can see. You can see with the second version, we are keeping the heat affected zone completely consistent from start to finish. We don't have these big comets that look like they're going through the sky. I don't want you guys to be practicing with filler rod at this stage. We're not to that step yet. You do not want to be practicing with filler rod until you have this down. Now, the two factors that I would say to practice this, if you're doing sheet metal, continuous pedal down, continuous heat affected zone, approximately 3/4 to an inch wide from end to end on your heat affected zone. When you can consistently have a perfect line through of the melting point, then we'll move into the third step. If you are practicing stacking dime, then I would highly recommend you start with 3/16. Get something that's maybe 2-inch wide strap steel at your local scrap metal place that you can practice on. And get cold rolled. Don't get hot rolled, because then you got to grind the mill scale off. TIG welder wants cold rolled steel. You can lay that 2-inch strip down and you can just make several coupons with it. And what you're going to do there is you're just going to be pushing the pedal and fluctuating till you see the puddle go full diameter for the amperage that you are welding. When you can stack consistent puddles, then you can move into filler rod. I see way too often people are trying to develop foot movement, their torch movement and torch angle, and they're struggling with just the basic fundamentals. Only practice these things before you even move into that. Otherwise, it's going to be a lot more of a struggle. Other common issues that I see is that people want to stay on the pedal and forget that they need to let off the pedal and wait for the post flow. The post flow setting is there to protect the tungsten from becoming contaminated before it has completely cooled off. What I will typically see is somebody doing the weld, and before they let off the pedal, they pull the torch back and the arc length just shoots off of the panel. You want to get in the habits of keeping your torch down close, and as soon as you get to the end of your weld pool, you let off the pedal slowly and you wait till you hear the post flow stop. We have ours set at about 6 seconds, and when the post flow stops, then you can move. These are very, very crucial things, because as soon as you finish and you just get out of it, you just contaminated the end of that TIG weld, and then when you restart it, you're just going to continue to drag it. You need to have clean sheet metal with a good ground. We have the metal table has been ground. We have the ground clamp on the side. And if you have a rusty panel where the backside's rusty, it's not going to make a good connection, and you're also going to struggle with trying to get this thing to have a good arc. Another common thing that I see is that people are too hyper-focused in trying to stay so close to the weld pool that they're dipping the tungsten in. And if you start to see the tungsten get hot or get contaminated, then you need to just stop, let the tungsten cool, take it out, regrind it, put it back in, and continue practicing. Or have multiple pieces on your bench of tungsten ready to go that you can just keep swapping out and practicing as you go. As soon as you dip it, the arc is going to want to jump all over the place, and you're not going to have that consistent arc that you want going where you need it. So this one's for the pulling off without letting your pedal off. That's a fancy one. That's a good one. And then I'll do another one where I stick it. When you stick it that good, you really got to break it off. And if it's already contaminated and you try to use it again, we'll see if it shows up on camera here. Of course it wants to work good.
Don't even need to sharpen it.
Yeah. I can't believe that it worked that good, because I buried that sucker, so I had to break it off. We're going to roll through and just give you guys a couple demonstrations as to what I want you guys to practice and what it should look like. Easing down on the pedal. Once you're down all the way, then start your travel speed. If you see the puddle go away or you're moving too fast like this, then you just need to slow down until you can watch the puddle follow. If the puddle looks like it's dancing around a whole bunch, then you're moving too slow. And you can even see in the center here where we just don't have any puddle. It's very inconsistent, and that's not what we want. And that's even with 48 amps. So you can play with your amperage. Remember, I would rather have it slightly higher than slightly under, because we want it to penetrate. We also want to be checking the back sides of our welds to make sure that it is penetrating. And we can run it again. So now we'll just put it at an even 53. We're 10 amps above what our thickness is. And if you guys don't have a steady hand and you're trying to just practice those fundamentals, you can set your wrist on the bench and use your other hand for the moment to just get in the habit of picking up that muscle memory for evenness. There's that dancing of the puddle. If you're there too long, there is a sweet spot where it just Slowly moves right along. Now, we want to stay till our post flow stops, and then we can move the torch out of the way. We are looking for nice even heat zones, nice even beads of the pool. We don't care about the filler rod yet. You can see this thing is taking off. We don't care about the warpage. You're going to get warpage whether you're using 3/16, 18 gauge. The only difference is you see it a lot more on 18 or 19 gauge versus 3/16. Although it's still going to pull, it's still going to move, you just see it more. If you guys stay tuned for the third segment of this video, we're going to show you guys how we remove all of this warpage, and this becomes a non-issue. But it's all based off of these fundamentals. Otherwise, it's a lot harder to remove. Run one more. Another good thing to practice would be if you're too close. Obviously, this is an air-cooled torch. It's not a water-cooled. You do not have to have a water-cooled torch. But if you have an air-cooled torch like this one and you're really close, you're going to find that this end gets really hot. The other factor there is that if you're back farther on the torch, you have a farther travel speed that you can go. Your arc length becomes shortened when you're choked up too tight. So it's almost better to be back midway, so that way you can pivot with your wrist. It's not an arm movement. It can be if you're that steady, but it's more of a wrist movement, at least for me, as you go across. When you want to become proficient at this, I highly recommend whatever steel that you're going to TIG weld, you take a notepad, put it in your phone, and have, for 18 gauge, I use X amperage. For 19 gauge, I use X amperage. Notate what gas flow you use for what cups. All of those things matter. That way, every time you go to do that kind of weld, you can set everything back up and expect the exact same result as you got before. Before we jump into the third step, I strongly cannot emphasize it enough. To master these techniques, let's recap. Torch angle, 15 degrees. Distance, about a 1/16 away. And a travel speed that has an even puddle with an even heat affected zone. With keeping in mind to make sure that when you stop, you're letting off the pedal slowly, and then wait for the post flow, and then remove yourself. Once you have that done, I want you guys to step into the third step, which is just implementing exactly what we did, but now we want to talk about the filler rod that we're going to use. This is ER70-S2. I believe that's what it is.
PQ.
Yeah, elemental PQ.
Tell me I'm wrong.
We've driven it home about amperage being so important and the metal thickness being so important. The third factor to this is that the filler rod is slightly thinner than the parent metal that we're going to be welding on. So here we have 43 thousandths, and we are going to be using 30 thousandths filler rod to then melt into it. The ideal situation is that we do not have to do an excessive amount of grinding like you would with a MIG welded seam. So what we want to practice here is, as you have the gas flow and the arc initiated, we are keeping our filler rod within a certain distance. I would say about an inch away, especially for this low of amperage, it's not going to be melting the filler rod away. If you are hovering too close to the tungsten, what happens is this starts to ball up, and then you don't have control of adding this. Another thing to keep in mind would be I don't use a glove, at least for me, on the filler rod because I can't feel 30 thousandths that well with a welding glove. So if I have the glove on the hot end, especially not being water cooled, I can just practice those fundamentals that are muscle memory. I've mastered it with practicing in step 2. Now I just need to focus on the third thing where you can bring this in.
You're gonna get skin cancer.
Yeah. So, if you want to become proficient with feeding the rod, it's just between your 2 fingers and your thumb is pushing it down. However, you could be sitting on your couch just practicing this movement back and forth. But more importantly, the filler rod has to be smooth and consistent. If you're just sitting on your couch feeding this thing, you're not going to be feeding this into your TIG welder like that unless you're pro, I guess, because I can't do it that way. But feeding at a consistent rate into your weld pool. Now, if you're doing perfectly stacked dimes into, say, 3/16, that is going to be where you are fluctuating the pedal and creating a pool and dipping into the puddle every time. However, with sheet metal, it's actually just maintaining that pedal to the floor to where you're not having blow through. The reason that we like having the pedal versus having just the button is, you can totally just use the button. But I find that where you're going to have an issue with the button is when you don't have a perfect fit up. When your fit up becomes a bigger gap, well, then it's going to want to blow away more, and then you struggle with that more. Where right now, we can pedal down for a good fit up. Right now, we don't have to worry about any fit up. We're just trying to practice how much we're going to add filler rod. Why? Because I don't want to have to grind down a bunch of excessive filler rod. You want to implement only enough filler rod to just fuse the two and have enough strength that we can hammer and dolly that out in the final segment of this series. So what we would like to practice is, you can just, as a visual reference, you can take marks approximately 1/4 inch or 1/2 inch apart. And those are the areas that you're going to dab. This is not a consistent dab motion into the weld pool to where you have this excessive weld seam. We want to do the exact same thing we did in step 2. Slow drag, dab every 1/4 inch or so. Nice and slow and methodical. And when you're holding this, you can totally do this where you may only have 8 to 10 inches sticking out past your fingers. And I like to think of this as a rolling wheel. You want this to just stay protected within that 1 inch near your cup, because if this is outside and you're doing these big dabs, you're contaminating the edge of this every single time that you leave and come back. We want to stay doing this nice, even rolling motion. And as we drag across, we only want to add filler about every 1/4 inch. And what that's going to do is it's just taking that little bit of 30 thousandths wire and it's adding a little bit of strength to the fusion of the two pieces. So in this case, we're just using one piece, not two, just to get the momentum going so that way you guys can see it on the camera where I'm dipping in the puddle. Also, if we pretend that this circle is our filler rod, Can you see that okay there? You like that?
Yeah, you see.
What we're actually aiming for in dipping in this rotating motion, if we pretend this is the molten pool, we're coming down and we're dabbing right at the leading edge. If you hit too far in front of it, it's going to ball up and then it's going to suck it in and it's not going to look how you want it to look. We want to always aim for just in front of the tungsten into the weld pool as it starts to melt. So let's check out what that looks like. Your mind wants to dip way more consistently. Versus dragging it out and barely adding any filler rod. That is ideal because there is such little filler rod there. It's more of a fusion than anything. If you have a whole bunch of dabs and you're just dabbing too much, well, then what happens is your weld seam is going to be thicker than what you're welding. And when you do go and stretch this back out later, you're going to have an area that is overstretched versus an area that is just right where you want it to be. Can you add more filler rod in the beginning? Absolutely. It's just going to take you a little bit more grinding or dressing of the weld. These are just some of the fundamentals that I wish I knew when I was first learning this to be able to perfect this now 15, 20 years down the road. If at any point we go to strike an arc here and the tungsten gets contaminated with the filler rod and we hit it, we will have to regrind that. So if you hit it and bam. I don't know if you guys can see that, but what it does is it just balls up right on the edge of the tungsten. And now you don't have a consistent arc as you're going through. You could continue to practice that way. It's just not going to be the most ideal situation. Just take it out, regrind it, and go right back into practicing. When we're looking at the heat affected zone here, how one looks more consistent than the other, it all has a factor in how much travel speed, how much you're dipping the rod, because this filler rod is not heated, it's cold. And theoretically, if we break down what's happening with the weld, like why does it V out and sink down in the center? As we are adding the cold filler rod, it is shrinking into the center line of that weld. The heat affected zone is actually slightly stretched. And in doing this, you have to understand that when you have the force outside of the weld pool, if it's shrinking and pulling in, and out here in the V and the heat affected zone is slightly stretched, it's pushing down. And that's why we get that look as we TIG weld. You just don't see it as much with thicker steel, although it will move. I mean, if you're thinking about doing a chassis or a roll cage and you're putting a weld seam along a joint, know that it's going to pull that tube down. And that's why a lot of times if you're doing chassis welds or a roll cage, you should think about doing all of your welds evenly spaced, where if you're going to do one on one side, know that you need to be doing it evenly on the opposite to then counteract that pull, and it will actually pull it back. There's good videos I've actually seen on YouTube. If you look up flame straightening, they use it in high-rise buildings to pull back massive I-beams, and it just gives you a really good understanding of how that heat will pull the metal in one direction or the other. And the reason that nobody likes to TIG weld sheet metal is because it just gets out of whack so fast that it's not usually obtainable, because the person that wants to try to do a nice TIG weld doesn't understand that even the perfect TIG weld gets warpage. It's understanding how to remove that warpage that's the most critical factor. Yeah, Mike asked, you know, what is creating the weld pool? And your torch is what is creating the weld pool. So when you guys see those stacked dimes, don't think that that's your filler rod. Sure, the filler rod is adding to that scenario, but what you're watching for is the fundamentals in step 2, which is that puddle. That diameter of the puddle is created with the torch, and you are keeping that puddle the consistent diameter as you move. So as you move, if you are moving too fast, that diameter will get a lot smaller, and then you don't have the penetration. So if you always think about the TIG torch as an actual torch with a fire flame like a settling torch, if you keep it in one spot, because it's just like gas welding. Gas welding is really not much different. You're putting it down till you can see a molten weld pool, and you're just moving to find that consistent melt point. Once you have the consistent melt point, we're just using this to then fuse it. If you didn't have filler rod, if you have a gap that is slightly too large, it will want to blow away, opposite of what you would think it would do. It's not always going to pull to the center of the weld. It's going to want to blow away, and then you'll have this massive hole. So what you're doing is you are pedaling down based off of your amperage and thickness. And if you have a gap, you are slightly letting up on the pedal, so that way you can compensate for that burn back on the gap, and then being able to fill that gap. And then when you're back into an area that has a better fitment, you can then carry on. So just remember, the filler rod does not create the weld. It is just filling the puddle that you are already controlling with the torch. Anytime that I go to a class to learn any one thing, whether it's metal shaping, body filler, anything, I always try to practice these fundamentals. That way I have more questions for when I get there in the class to be asking, so that way I get my money's worth. If you guys are gonna go out and do this, the whole purpose of this video was that you had a machine under $200 that you could buy an Argon bottle and a regulator and be up and running. I would say if you found a used bottle you could probably have the whole setup for $300 to $400 and be practicing. If you guys are at home practicing this and you're struggling and you still want more in person, feel free to look at sylvesterscustoms.com. We just updated the whole schedule for upcoming classes, and we're always looking to add to the value in what you guys are doing in your project.
If you're struggling with your projects, go to sylvesterscustoms.com, check out the dates we have up, come to a class, I will work with you personally.
And I will work with you personally.
I will work with your mom if she signs up. I will work with your dad, whoever you want to sign up, I will work with them.
In the next video, we're gonna take 2 pieces, butt them together, and do an actual weld seam. And we're gonna drive home the #1 factor that everybody has with TIG welding is how to remove. If you guys haven't subscribed, please subscribe, like, share with your friends. It helps us on the channel. We'll see you on the next one. Follow the series. This series. Hold on, one more time.
In this video.
In this video. In the next video. What? Dick. Hey, we did one, dude.
This next video.
Hey, how much time we do that in? And we ate dinner.